Welcome back. In this segment, we'll talk about dimensional analysis. What is really dimensional analysis? Dimensional analysis is a procedure used to convert between units in solving chemistry problems. Sometimes it is also referred to as factor label method. When you do dimensional analysis, you have to keep several things in mind. Some of them are here. Always write every number with its associated unit. Very important. Always include units in your calculations. Extremely important. You can do the same kind of operations with units as you can do with numbers. So therefore, keep them always in mind. Say for example, centimeters by centimeters will give you square centimeter. Centimeter plus centimeter is simply centimeter. Centimeter minus centimeter is simply centimeter. If you divide centimeter by centimeter, the units cancel, so therefore it becomes 1. So, in other words, using units as a guide to problem solving is called dimensional analysis. Also, don't forget, many problems in chemistry involve using relationships to convert one unit of measurement to another unit of measurement. So if that is the case, we can create conversion factors based on relationships. So in other words, they may be measured. So let's take an example. Conversion factors can be generated from equivalence statements as well. 1 inch is exactly equal to 2.54 centimeters. So that is a definition. Now how do we generate a conversion factor? The conversion factor is either 2.54 centimeters by 1 inch or 1 inch divided by 2.54 centimeters. If you are going to convert inches to centimeters, say you are going from inches to centimeters, you would use this as a conversion factor. That way you can cancel out the inches from the starting measurement and the equivalence factor denominator. If you are going from centimeters to inches, in which case you would use this as a conversion factor wherein you can cancel out centimeters. So you arrange conversion factors so that the starting unit cancels. So you would start with unit 1 times unit 2 divided by unit 1 of your conversion factor. When the unit 1 gets cancelled, it ends with unit 2. Let's start with an example. How many milliliters are there in 1.63 liters? So remember the definition. 1 liter is equal to 1000 milliliters. So our definition for conversion is 1 liter equal to 1000 milliliters. So that means that I can write the conversion factor here. It is 1 liter over 1000 milliliters or 1000 milliliters over 1 liter. Notice that you are going from liters to milliliters, and so therefore you want to cancel milliliters. The conversion factor you want is 1000 milliliters over 1 liter. So let's take what is given, which is 1.63 liters times 1 liter is 1000 milliliters. Well, liters gets cancelled. That would now give you a value of 1630 milliliters. So you can also see I have solved this already on the slide. So this is what you would do using conversion factors. Let's do one more, which is little more difficult. The speed of sound in air is about 343 meters per second. What is this speed in miles per hour? So let's get conversion units first. We have to go from meters to miles, seconds to hours. Notice you have meters per second, you have to go from meters to hours. Okay, 1 mile is exactly equal to 1609 meters. It is given. Sometimes when a problem of this type is given, we will give you some equivalence units. You don't have to memorize everything. We already know 1 minute has 60 seconds, 1 hour has 60 minutes. So let's write the conversion factors. Remember, we are going from miles to meters, so that means miles are going to be in the denominator in your conversion factor. So 1 mile divided by 1609 meters. Then we want to go from seconds to minutes. Minutes will be in the denominator, and then from that we want to go to hours. So you will have 60 minutes per hour. Okay, so now let's set up the string equation. You have 343 meters per second times the conversion factor for miles to meters times the conversion factor from seconds to hours. So you have two different ones, and multiply everything in the denominator and then multiply everything in the numerator and then divide the two. You get 767 miles per hour. So this is a way to do dimensional analysis, especially when you're doing conversion from units of one type to the other. Let me explain yet another way to do dimensional analysis. This is more of a systematic approach. This approach involves 6 steps. You must write down the given amount and the unit first. So that's the first step. Step 2, write down what you want to find and its unit. Number 3, get the conversion factors or equations that you need. What do you need? Write down the equivalent statements for each relationship, change the equivalent statements to conversion factors, and such that the starting unit is in the bottom and it gets cancelled. Number 4, create a solution map. A solution map is something that will order all the conversion factors such that the previous units gets cancelled and you will end with the unit of what you want to find. Apply the steps in the solution map. Check to make sure you have cancelled units correctly. Multiply across the top and then divide from the bottom to. Also make sure to check if your answer is reasonable and the correct size of the unit is appropriately expressed. Let's take an example and do this systematic approach. Convert 7.8 kilometers to miles. Okay. Remember, step 1, write down what is given. Given is 7.8 kilometers. Write down the quantity you want to find and its unit. To find is miles. You need to know how many miles is 7.8 kilometers. So we write down. Write down the appropriate conversion factors. Conversion factors. 1 kilometer is equal to 0.6214 miles. Now write a solution map. Solution map is going from kilometers to miles. So that means my factor, conversion factor, is going to be 0.6214 mile divided by 1 kilometer. Now I apply the solution map, start with the number and the unit given, which is 7.8 kilometers. Multiply that by the conversion factor that I created up in step number 4, and I get this number. Now make sure the answer has correct significant figures. Notice I have two significant figures in the quantity given that I started with, so that means I should end with that. So in other words, one decimal place. So if I would end there and I would simply truncate this, that will be 4.8 miles. Now check this answer. Does it make sense? Miles are larger, kilometers are smaller. So that means if you have larger kilometers, you should end up with smaller miles in terms of magnitude. So therefore 4.8 miles makes sense. Also look at its definition, the conversion factor. It also makes sense. Okay, so this is how you apply the solution. Let's do some examples, at least one or two, and then we'll stop on this segment. Okay, 2.4 kilometers is how many millimeters? Okay, so you'll have to pick the correct answer from the list. Let's start with what is given. Given is 2.4 kilometers. Find how many millimeters it is. Okay, so we can write down our definitions. 1 kilometer is equal to 1000 meters. We know this. 1 meter is equal to 1000 millimeters. We know this. Okay, so now we have to arrange conversion factors. Remember, you are in kilometers, you need to cancel kilometers. So therefore my conversion factor from this is going to be 1000 meters divided by 1 kilometer. And in the second one, my conversion factor, I will have to cancel the meters and I have to go to millimeters. So it's 1000 millimeters divided by 1 meter. Okay, so now let me create a solution map. Solution map is going from kilometers to meters to millimeters. So that's what I'm doing. Now let me apply the solution map, and I have the correct conversion factors here. So I have 2.4 kilometers times 1000 meters divided by 1 kilometer times 1000 millimeters divided by 1 meter. Can cancel kilometers and kilometers, meters and meters. I will end with the millimeters. So that would be equal to 240,000. Now the decimal place is here. Let me express this in scientific notation. So that's 1, 2, 3, 4, 5, 6. That's that's equal to 2.4 times 10 to the 6 millimeters. So that is the way the answers given are. So therefore my correct answer is going to be D. I hope you can solve like this step by step and show the correct answer. Let's do one more example. Suppose a house has a floor area of 2250 square feet. What is this area in units of square centimeters? This is again, a problem which involves conversion of units, and it is important that you pay little attention to your conversion factors. Okay, so let's see what is given. Given 2250 feet square. You need to convert this to how many centimeter square it is going to be. Okay, so let's, based on our knowledge, write down the conversion factors. 1 feet is equal to 12 inches. That means 1 feet square is equal to 12 inches times 12 inches. That's equal to 144 inch square. Now let's also do the same thing with centimeters. 1 centimeter is equal to, I'm sorry, I take that back, 1 inch is equal to 2.54 centimeters exactly. So therefore 1 inch square is equal to 2.54 centimeters times 2.54 centimeters, and if you multiply, that will give you a value of 6.45 centimeter square. Okay, so now we know this. We know 1 inch square is equal to this much. 1 feet square is equal to 144 inch square. Now let's get to the solution map. You want to go from feet square to inch square to centimeter square. We have 2000. We are going to apply the solution map. We have 2250 feet square times 1 feet square. We found out that it is going to be 144 square, I'm sorry, inch square times use the next conversion factor. 1 inch square is 6.45 centimeter square. So now you can cancel out feet square, inch square, and that will give you a value of 2089800 centimeter square. We want to express this in scientific notation. Notice your answers are in scientific notation, and all of them have 3 significant figures, so we should have 3 significant figures in this case. So it's going to be 1, 2, 3, 4, 5, 6. So that's 2.089800 times 10 to the 6 centimeter square, or because you want to keep 3 sig figs, it would be 2.09 times 10 to the 6 centimeter square. Alright, so let's look at the correct answer. Correct answer seems to be B, and that is how you make this conversion.